Welcome to second episode of CSAT LTP, that is Learn Through PYQs. In the previous episode, we learned the concept of percentage, and this video we will learn the concept of compound interest through PYQ. So take a look at this question. This was asked in the year 2023. Take a read. A principal P becomes Q in 1 year when compounded half yearly with R% annual rate of interest. If the same principal P becomes Q in 1 year when compounded annually with S% annual interest rate, then which of the following is correct? R equals S, R greater than S, R less than S, or R less than or equal to S. So to answer this question, we need to first understand what compound interest is and how the compound interest formula works. So let us understand the formula for compound interest now. So this is the formula. The basic formula for total amount in the case of compound interest is Q equals P into 1 plus R effective percentage raised to N or to the power of N. Now in this formula, Q is the total amount. But what is P, what is R effective percentage, and what is N? See here, P stands for principal. So what is principal? Principal is the amount that is lent or borrowed. For example, if you lent 1000 rupees to your friend at some compounding interest, that 1000 rupees is principal. That is the amount lent or borrowed. Then what is R effective percentage? You know, the formula for simple interest is very easy. So the simple interest formula is SI equals PTR by 100. Principal, time period, R interest divided by 100. But it is not so simple when it comes to compound interest. Let us say you lent 1000 rupees to your friend at 10% annual interest, but compounding half yearly for a total period of 1 year. In that case, R is 10%, but compounding I is occurring half yearly. That is, compounding occurs once every 6 months. It is mentioned while the transaction is taking place, that is the lending and borrowing, the compounding frequency is mentioned. So in this case, compounding has been agreed upon on what period? Half yearly. So this annual rate of interest, it is per annum. Rate of interest is always per annum, 10% per annum. But compounding occurs 6 months, right? For every 6 months, as per the agreement between you and your friend. So for 12 months, it is 10%. So how much is it for 6 months? That is 5%. Why 6 months? Because you have agreed that you will compound the interest half yearly. That is, you have agreed that you will be compounding the interest every 6 months. So R effective is given by R divided by number of compoundings per year. So R effective is given by R divided by number of compoundings that happen per year. So in this case, in you and your friend's case, you have lent 1000 rupees at 10% per annum interest rate, and you have agreed that compounding will be happening half yearly. So there will be 2 compounding happenings in 1 year. So R divided by 2, that is 10 by 2. So R effective will be 5. Then, so this is R effective. Then what is this N? N is, okay, to understand N, let us slightly modify the agreement between you and your friend. So let us say you lent 1000 rupees at 10% per annum rate of interest, compounding half yearly, but you lent the amount for a period of 2 years. Now N is the total number of compoundings that happen throughout the time period. So in this case, compounding is happening half yearly. That is, compounding happens once every 6 months. How many such 6 months are there in 2 years? There are totally 4 compounding cycles. So n will take the value 4. So in your case, the total amount Q will be 1000 into 1 plus 5% raised to 4. So this is how the formula for compound interest works. Let us understand it better with another example. Take a look. Principal 1 lakh rupees becomes Q in 1 year when compounded half yearly with 20% annual rate of interest. Find Q. Let us use the formula. Q equals P into 1 plus R effective percentage raised to N. So here P is 1 lakh rupees, it is readily given, and then R is 20. But what it is R effective? R effective is 20 divided by a number of compoundings per year. So how frequently does compounding occur here? Again, it is said to be half yearly, right? So compounding occurs once every 6 months, and the total time period is no need of total period. So if compounding occurs once every 6 months, so 2 compoundings will happen per year. So this will be 20 divided by 2, that is N. And then what is N? Again here, the total time period itself is 1 year. So N is given by total number of compoundings for the time period. Here that is also 1 year. So for 1 year there will be 2 compoundings. So N is 2. So this formula will be, okay, I will rub this off. So this formula will become 1 lakh 1 plus 5%. 5% is nothing but, okay, not 5%. So 20 other 10, no? Yeah. 10 divided by 100 raised to 2. So this will be 1 lakh. 10 divided by 100 is 1 by 10, that is 0.1. So 1 plus 0.1 whole square. So this will be 1 lakh multiplied with 1.1 whole square. And we know that 11 square is 121. So 1.1 square will be 1.21. And this will come up to 1,21,000. So this is the final amount in the case of this question. So this is Q. So we understood how compound interest works, and we understood how to use the formula for compound interest. Now let us try to answer that question, but before that we need to understand a few more basics. See, in the formula for the total amount in the case of compound interest, Q equals P into 1 plus R effective percentage raised to N. Q increases if which of the following parameters increase? P, R, T, N. So here, okay, T stands for time period. Now, if P increases, Q increases, that is readily available there. That is readily obvious there. R, yeah, because if R increases, R effective will also increase. For that reason, if R increases, then Q will also increase. And T, N and T, they are complementary. If N is more, T will be more. If T is more, N will be more. And if either of them are more, then Q will be more. So together, if both of them increase, then also Q will increase. So Q is dependent on all the 4 factors proportionately. So if any of these increase, Q will also increase. Okay. Let us see the converse of it. Again, in the same formula, Q decreases if which of the following parameters decrease. Again, if any of these parameters increase, Q will increase. The same way, if any of them decrease, Q will also decrease. So if P decreases, Q will decrease. If R decreases, R effective will decrease. And if R effective decreases, then also Q will decrease. If T decreases, N decreases. And if N decreases, so to the power of something, if it decreases, then also Q value will be decreasing. So here also the answer is 1, 2, 3 and 4. And in the previous question also, the answer is 1, 2, 3 and 4. It means that our total amount in the case of compound interest, it is dependent on all these factors. Okay. Now take a look here. With respect to the aforementioned formula, that is the formula that we have been discussing so far, For the total amount in the case of compound interest, Q equals P into 1 plus A effective percentage raised to C, and Q equals P plus B effective percentage raised to D. That is, here this is the R effective percentage and this is the R effective percentage. They are calculating it in two separate instances. And this is the number of cycles and this is the number of cycles. Then it is given that A is greater than B. Then what is the relationship between C and D? Okay, how do we calculate it? See, in both the cases, P is the principal. And in both the cases, Q is the total amount. So, if A is greater than B, then actually this total amount should have been greater than this amount, right? Because A is said to be greater than B. But still, even when you do this calculation, you get Q. Even when you do this calculation, you get Q. How is that possible? It is only possible if C is less than D. Why is it so? Because A has increased the value of this expression, but by that logic, the total value should have been increased. But C must be less so that the value addition made by A has been counterbalanced by C. If A is greater than B and if C is less than D, there might be such a case where the increase of A with respect to B can be counterbalanced by the decrease of C with respect to D, such that you will get the same value in both the cases. Okay? So this is the logic, but let us understand this logic better with a specific example. See, in this case, a principal P becomes Q. Okay, this is the question. Before going this, let us take a look at an example. Principal 1 lakh rupees becomes Q in 1 year when compounded half yearly with 20% annual rate of interest. If the same principal 1 lakh rupees becomes Q in 1 year when compounded annually with 21 annual rate of interest, then find Q. So in both the cases, Q is same. Let us see how it happens. By looking at this example, you will better understand what I meant to say with that example of A effective percentage and B effective percentage. So let us break this question into two parts. Now let us apply the formula for the first case. So Q equals P into 1 plus R effective percentage raised to N. So in this case, the principal is 1 lakh rupees. 1 plus, now 20% is R and the compound is occurring half yearly. So R effective will be 20 divided by number of compoundings that happen per year. So it is half yearly compounding. So compoundings will happen 2 times in a year. So 20 divided by 2, this will be 10%. And 10% is nothing but 10 by 100. And what is the total time period? The total time period is 1 year. So N is given by the total number of cycles in the given period, and here that given period itself is 1 year. So there will be 2 compoundings. So this will be 2. So this value will be 1 lakh and this is 1 plus 0.1 whole square. Actually, we have already solved this question. So this comes to be 1,21,000 rupees. Done. Now let us solve this second part. In the second part, again we will apply the same formula. Q equals P into 1 plus R effective percentage raised to N. Here the principal is again 1 lakh. And here the rate of interest is 21%, not 20%. Okay. If it is 21% and compounding is happening annually. So if compounding is happening annually, then how many compounds actually happen in 1 year? Only one compounding will happen 1 year. So R effective will be 21 divided by 1, it will be 21%. So this will be 21 divided by 100. And the total time period is 1 year. So if the compounding is happening once every year, only one compounding happens throughout the time period. So this will be 1. So if you solve this, this will be 1 lakh into 21 divided by 100 is 0.21. 1 plus 0.21 is 1.21. To the power of 1 does not matter, because anything to the power of 1 is itself. So 1.21 into 1 lakh, its value will be 1,21,000. So in both the cases, the total amount is same. How is it possible? Because here compounding was happening half yearly and the rate of interest was 20%. But here compounding was happening annually and the rate of interest was 21%. So even though the rate of interest increased, the compounding frequency decreased. So they counterbalanced each other, as I have shown here. So even though A is greater than B, if C is less than D, then they will counterbalance each other. So now we are well equipped to answer that PYQ that we saw in the first page. This is the question. A principal P becomes Q in 1 year when compounded half yearly with R% annual rate of interest. If the same principal P becomes Q in 1 year when compounded annually with S% annual rate of interest, then which of the following is correct? See, in the first case, this R%, in the first case, the compounding frequency is twice every year. And in the second case, because it is half yearly. And in the second case, the compounding frequency is once every year. And here, the rate of interest is R%, and here the rate of interest is S%. So, if the compounding, so by that logic, R should be less than S. That is your answer. Okay. I think now you understood how to answer this question confidently. Now let us take a look at, okay, now it is time for a homework question. Take a look at the question. A principal P becomes Q in U years when compounded half yearly with R% annual rate of interest. If the same principal P becomes Q in V years when compounded quarterly with R% annual rate of interest, then how many of the following conclusions is/R definitely correct? R less than U less than V, S less than U. So you need to evaluate all the three statements or conclusions and give the answer. I will discuss the answer in the next episode. By that time, leave your answers in the comments. And now it is time to answer the homework question of the previous episode. So this was the question given to you in the previous episode. The price M of a commodity is increased by K square percentage 3 times and then decreased by K square percentage 3 times. If the new price is N, then what is the relationship between M and N? Again, this is dependent on the concept of percentage increase and percentage decrease. So M is the initial amount, initial price of the commodity. If you increase it by K square percentage, its value will be 100 plus K square divided by 100. And if you repeat it 3 times, it will be just cube of it, that's all. Then, and we don't stop there. What do? We decrease this value by K square percentage again. So if we decrease this entire value by K square percentage, its value will be 100 minus K square divided by 100. And we don't stop there, we repeat it 3 times. We do totally 3 times. So again, we need to cube this as well. And this new value, it is said to be N. Okay, let us simplify this equation. M into, see, you have 100 plus K square whole cube and 100 minus K square whole cube. So can we take whole cube common, as in 100 plus, no, let us not take whole cube common. 100 plus K square, this value will be 100 plus K square into 100 minus K square whole cube of this. Then divided by 100 cube into 100 cube. Equals N. And this is of the format A plus B into A minus B. So A plus B into A minus B, it will be A square minus B square. So this whole value will be 100 square minus K square square. So the square of K square, it will be K power 4. Because we know that A power M whole raised to N, it is A power Mn. By that logic, K square whole square, it will be K power 2 into 2, that is k power 4 whole cube divided by, now 100 cube into 100 cube, this is given by a power m into a power n is a power m plus n. So 100 cube into 100 cube, it will be 100 power 6, and this is said to be m. Now we can further do something about this 100, because we know that 100 is n square. So if we apply it here, m into 10 square whole square minus k power 4 whole cube divided by 10 square whole power 6 equals n. Again, this will be 10 square whole square will be 10 power 4, and 10 square into 6, power 6 will be 10 power 12. So this will be m into 10 power 4 minus k power 4 whole cube divided by 10 power 12 equals n. And in the equations, in the given this things, so this seems closest. So let us bring it to that format. M into 10 power 4 minus k power 4 whole cube is equal to 10 power 12 into m. Now this exactly matches with option C, and that is our answer. Okay, so if you like this video, do like and do watch us regularly. We upload one episode every day. So thank you, all the best, and most of all, a very happy learning.